Our first step is to get everything to one side of the equation, or the inequality, so that we have a 0. So we're going to subtract the x and the 1 over to the left side. So minus x and minus 1. That's less than or equal to 0. The next thing is we need a common denominator. So because we need a single fraction here. So x minus 2 is our denominator here. So this minus x minus 1, we need a fraction with a denominator of x minus 2. I'm going to go ahead and actually leave this like that. And then I think that'll help us a little bit with this next step of writing out that common denominator. So I have minus, and the x plus 1 is multiplied by an x minus 2 on top and on bottom. Now I can go ahead and multiply all of this out and write this as a single fraction. So minus, and then I'm just going to, in parentheses, go ahead and distribute everything here. So x times x is x squared, and then I've got a negative 2x and a plus 1x, which is minus x, and then a negative 2. And that's all over x minus 2. Okay, now we can distribute that negative in the numerator. So we have our 2x squared minus 2x minus 14, and then minus x squared plus x and plus 2. And that's all over the x minus 2 and less than or equal to 0. Now we can combine like terms. We have 2x squared minus x squared, which is x squared, minus 2x plus x, which is minus x, and minus 14 plus 2, which is minus 12. And that is over x minus 2. And this is less than or equal to 0. We now need the zeros of the numerator and the denominator, so we're going to need to factor the numerator here. That factors as x minus 4 times x plus 3. Now, our zeros. From the numerator, we get x equals 4 and x equals negative 3. For our denominator, we get x equals 2. We set each of these on a number line. Negative 3, 2, and 4. We'll label them as whether or not the rational function is 0 or undefined there. So those from the numerator are give us actual zeros, and so we have a 0 here and a 0 here. And at 2, that came from the denominator, it's undefined. Okay, now I need to check each of these intervals created by these points. I only need to really plug one number in. Let's go ahead and plug 0 in because it's an easy number to plug in. If I plug it in right here, my unfactored form, it's a little bit easier. I get negative 12 over negative 2, which is positive 6. So this is a positive on this entire interval. Now, the negative 3, 2, and 4 each had a multiplicity of 1. And an odd multiplicity means that it will change as we cross that point. So from the positive, as I move to the left and cross at negative 3, it changes to a negative. As I move to the right from positive, I change to a negative, and then I change back from negative to positive. We are solving the inequality where this is less than or equal to 0. So that means negatives. So I have from negative infinity up to negative 3. And because it's less than or equal to 0, I will include the places where it equals 0. So I'll include the negative 3. And I also have this interval from 2 to 4. I can't include 2 because it's undefined there, but at 4 it's equal to 0, which satisfies this inequality. So I do include that. And that is the solution to my rational inequality.